Hello and welcome. We will discuss PYQs of ratio and proportion in this video, and our theme is basic problems of ratio and proportion. Let's solve the problems now. The problem 1 says out of 120 applications for a post, 70 are made. If total application are 120 and 70 are male, so there are high chances that remaining 50 should be female. 80 have a driver's license. Out of 120, 80 are with driving license. WDL, meaningly with driving license. So remaining 40 should be without driving license. What is the ratio between the minimum to maximum number of males having driver's license? If we want to find out minimum number of males, then all the females must have, if we want males to be minimum, so all the females must have driving license. So total people with driving license are 80. Out of 80, now we are assuming that 50 women or 50 females are having driving license. So minimum number of males having driving license should be 30. So 30 is the minimum value. For maximum number of males, what we will try to do, we will try that all the males have driving license. Total people with driving license are 80 and total males are 70, right? 70 is less than 80, so it is possible here that all 70 male has driving license. Okay, so minimum male are 30 and maximum male are 70. So 30 is to 70, which means ratio should be 3 is to 7. Option D. Now in this question, minimum is written first, so the number that represent minimum value should be written first, and maximum is written second after the word 2. So the number which represent maximum male should be written after this symbol. So answer should be option D. Kindly make a note of it. Kindly make a note of it. And this question is very easy. Now let's move on to the next problem. It says 30 gram of sugar was mixed in 180 ml water in a vessel A. So in vessel A, sugar is to water. Sugar is to water is 30 gram is to 180 ml. Okay. And in vessel B, sugar is 40 gram and water is 280 ml. In vessel C, sugar is 20 gram and water is 100 ml. So we have to, the solution in vessel B, we have to compare solution of other vessels with the vessel B. Now in this question, guys, if I want to talk about concentration, if I want to talk about this figure, this vessel A, right, in this 30 upon 180 becomes 1 by 6 gram per liter. 40 upon 280 becomes 1 by 70 gram per liter per milliliter, and 20 upon 100 becomes 1 by 5 gram per milliliter. Now if I compare these fractions, so numerator is same everywhere, numerator is same everywhere. So the fraction with highest denominator will be the maximum fraction. Oh, sorry, will be the minimum fraction. So B should be the minimum value. Since numerator over here are same, so the fraction with highest value should be minimum. So 1 by 7 will be the minimum value. 1 by 6, the next greatest, and the greatest should be C. So 1 by 7 should be minimum. 1 by 6 should be next greatest. And the greatest of all should be 5. Now, see, lesser the concentration, lesser will be the sweetness of sugar. So, vessel B, the mixture in vessel B is least sweet, and the mixture in vessel C is highest. The highest sweetness is in the vessel C. So, the solution in vessel B is sweeter than C? No. Solution in vessel B is less sweet. It is less sweet than C. So option D is the right choice here. Solution in B is less sweet than C. Kindly make a note of it. Okay. So let's move forward now. Next is, there are 3 points P, Q and R on a straight line such that PQ is to QR is 3:5. So let's see, PQ is 3x and QR is 5x. We have assumed the distance between P and Q as 3x and the distance between Q and R as fx. If n is the possible values of PQ is to PR, then what is n? So how many ratios are possible between PQ and PR? So I don't know the positioning of these 3 points. I don't know the positioning of these 3 points. So let's assume the positioning first. So let's say on the line P was present first, then Q was there, and finally R was there. I know the distance between P and Q is 3x and the distance between Q and R is 5x. So this kind of arrangement is possible here. So this is our case 1, and from this case, if we want to find out PQ is to PR, then PQ is 3x and P to R 3x plus 5x, which is 8x. So ratio is 3:8. This is one of the feasible ratio. Now let's assume in this case Q is lying between P and R. So in case number 2, let's assume Q is lying. Let's assume P is in the between. P is in the middle. So Q on the right, P in the middle, and then R is present. Okay. Now we know that Q to R, this complete distance Q to R is what? 5x. And P to Q is what? 3x. So P to R must be 5x minus 3x, which is 2x. Now the ratio of PQ is to PR must be equal to, PQ is 3x and PR is 2x. So ratio is 3:2. So this case is also possible, also feasible. So Q can lie between P and R, P can lie between Q and R. Now the next case is when R is lying between P and Q. R is lying between P and Q. Now we already know that P to Q is 3x and Q to R is 5x. So how is it possible that a distance of 3x is larger than 5x. Is 3x larger than 5x? No. So this case is not feasible here. So only two cases are possible. The first, when Q is in will lie in between P and R, and the second case when P will lie between Q and R. So only two cases are possible. So answer of this question is option B. Kindly make a note of it. So this is all for this video. We'll meet you in the next. Till then, please take care and bye bye.